Hi, today we are going to be solving a physics problem. The question we are going to solve today is the basketball and tennis ball. The question asks, a tennis ball with mass m2 sits on top of a basketball with large mass m1. The bottom of the basketball is a height h above the ground, and the bottom of the tennis ball is a height h plus d above the ground. The balls are dropped. To what height does the tennis ball bounce? Well, first, let me show you a simple virtual simulation of this experiment. Here is a virtual simulation of the balls falling. Ball 1 is a basketball and ball 0 would be the small tennis ball. Here's the simulation. As you can see, the small tennis ball would have flown very high in the air. But now let me show you another real experiment. Here is a video from the YouTube channel Bruce Yanni. He is demonstrating the actual basketball and tennis ball experiment.
Now, instead of jumping them side by side, what about if I put the tennis ball on top of the basketball? Well, let's see what happens.
As you can see, the tennis ball flies really high into the air just like the simulation as shown before. So from our first drawing, we see that the tennis ball and basketball are both in the air and are about to make contact with the ground. So we can label both balls with their respective masses. M1 is a basketball and M2 is a tennis ball. H is the height of the balls relative to the ground. On our second drawing, we see that both the tennis ball and basketball are at contact at the lowest point relative to the ground. So both of their velocities is pointing down to the ground. For our third drawing, just as you see in the short video, we see that both the basketball and tennis ball are bouncing back to the air and away from the ground. So in this instance, both of their velocities is pointing up since they are both bouncing up to the air. So first, we are going to apply the law of conservation of energy, which states that energy can neither be created nor destroyed, only converted from one form of energy to another. So here's the formula. 1/2 mv squared is equal to mgh. Now that we have our formula, we are going to manipulate the equation in order to find the velocity v. So let's do it. So starting from the equation, we want to get rid of the 2. So we will multiply by 2 on both sides, like so. Like this. So the 2 on the left will cancel out and our equation becomes mv squared is equal to 2 mgh. So now we want to get rid of the m on the left side, and we will do that by dividing by m on both sides, like so. These 2 cancel out, cancel. And our equation now becomes v squared is equal to 2gh. So again, since we have the squared, if you guys want to get rid of the squared, you have to square it to the other side. So we could also write it as v is equal to square root of 2gh. So just keep that in mind. So this is our velocity that we solved using algebraic manipulation. Now we have the v velocity. So looking at our third drawing, we see that both the basketball 1v and the tennis ball 2v are both traveling up. So their relative speed becomes 1v. Let's see, 1v plus 2v is 3v. So 1v plus 2v is equal to 3v. Yes. So there's our relative speed, 3v. So by our conservation of energy, the height becomes h is equal to d plus 3v squared divided by 2g. And so just for a quick simplification, since we have the squared right here, 3v squared, the 3 squared becomes 9, and the v squared, as you see right here, becomes 2gh, like so. And so just Using this, rewriting the equation, we're going to get H is equal to D plus 9 times 2 GH over 2G. Our equation is like this now. So again, we can simplify by crossing out the like terms. In this case, it will be the 2G's. So we can cancel them out. Cancel out, cancel out. And so we're left with H is equal to D plus 9H. So this is our answer. If we wanted to find the height of the tennis ball when it bounces in the air, this is the formula that we would use. So thank you, and I hope you enjoyed this video. Thank you.